All right, kind people. We're in the last section. We have our test on Monday. Hopefully we can get through everything today. And so we are in the last section right here, 8.3. And 8.3 is testing a proportion P. So again, it's the same idea, but this time we're doing a proportion. And hopefully a proportion right here, remember, is a situation, excuse me, when you have two possible outcomes, right? Your yes or no question, or I'm with them or I'm against them question, or I like it or I don't like it kind of question right here. Your proportions. And again, it remind you of your notations from your proportions. P is the probability of a success. Therefore, the probability of a failure is going to be 1 minus P. So if you have an 80% chance of being successful, that will mean you have a 20% chance of not being successful. And then out of the n number of people that you sample, R is the number of people who agree or say yes, or who say I'm for it. All right? So for example, if I ask you, do you like the color orange? And say out of the 25 people in here, say 30, say 20 of them say yes, they love the color orange, right? So then R would be 20, N would be 25. All right, questions there? And of course, P hat right here is your sample proportion. I asked the entire university whether or not they like the color orange, right? I only asked a sample of you guys. And so that gives us a value of P hat. P is the population proportion value. It's if I ask every single FAMU student, do you like the color orange? That would give me, divided by a total number of FAMU students, that will give me my P. Question there? All right. Okay, the same basic assumptions that we had the last time. Same basic assumptions we had the last time, that mu equals P, and the standard deviation, well, the standard error rather. Hold on, so student, give me one second. Yellow. Oh, the quiz was take home, but yes, just send me an email. I'll reopen for it. All right. All right, so yeah, so you have right here your standard errors, the same one that we used previously. Again, nothing's changing. And again, you have this key. Again, remember from 7.3, you have this key factor right here. That's your n must be large enough. N times p and n times q must be both greater than 5. Yes, you guys remember this stuff right here? Your assumptions? I remember when you did the homework questions, they asked you about them, and you said, remember, number is always 5? Yeah, maybe? All right, all right. And so, of course, you follow the same processes right here as you did before. Again, the idea is to simply calculate the p-value and then compare the p-value against the alpha level. Do you guys remember the rule? When do you reject the null? When the p-value is smaller than the alpha level, we have to reject the null. So if the alpha level, for example, is 5%, if the p-value comes in at 3%, then we reject the null. All right? Questions there? If the alpha level is 5% and the p-value comes in at 20%, 0.2, then you fail to reject the null. All right? Questions there? Questions there? All right, and then that takes us into our last slideshow. Oh, next week, Friday is our deadline for all your assignments to be in. Because Saturday is when I will send out the messages for all those who have an A in the course. So everything needs to be done by Friday. You have an A in the course, you do not have to take the final exam. But of course, if you want to, you can always come join us. You want to. All right, you can always come join us. All right. So continuing our testing for proportions. So of course, we're going to do a word problem. And like I have apologized several times, these word problems take forever. All right. So in a recent Gen 2Z American college student survey, 450 female college students rated the social network site Facebook as cool. That hasn't aged well. Assume that the survey was based on a random sample of 500 students. A marketing executive at Facebook wants to advertise the site with the slogan, more than 85% of female college students think Facebook is cool. Can you conclude, based upon the survey, that the marketing executive's claim is true? Do it at the 05 level, at the 5% level of significance. All right. So first things first, do you understand what they're trying to do? They're trying to do a hypothesis test. Yes? All right. And they're trying to say more than 85% of college students think Facebook is cool. That's the basic thing right here. And then this is their evidence right here. 450 out of 500 people said so. How many people think Facebook is cool? That hasn't aged well. Yeah, back in the day when Facebook just started, only college students were using. That's actually how it started. And then it was cool, but yeah, I digress. All right, so let's go ahead and run through the assumptions and then let's run through the test. Again, you'll run the test on SALT, so I will show you how to do that as well. All right, so let's check the assumptions. We have to check the assumption that the sample size is large enough. Okay, so there go n times p and then n times q, which means we need to find p and q first, yes? But the thing is, we don't have p or q, and so instead, what we're going to do is we're going to use, oh, apparently we do have p, my bad. We're going to assume that p is 85%, and so therefore q is 15%, and so then I can multiply those two together, and n times p is 425, n times q is 75, and of course, both of those numbers are greater than 5. Yes? And so that means we are in business. We can step forward. If this was not the case in real life, one of two things would have to happen. Either you'd have to go out and get more data, survey more people, or you'd have to use a different statistical process to try and get yourself to an end. All right? But that's not our problem right here. And so the assumption of normality is justified. And so we can move on to the next step right here of actually running the test. So what are the known alternate hypotheses? Anybody? The null hypothesis is a hypothesis on the percentage of people who think Facebook is cool. Mu is equals 85 or 0.85, and the alternate hypothesis is mu is going to be greater than 85%. That's right. So that's your null, and that's going to be your alternate hypothesis, right? Questions there? For a lot of scientists, for a lot of people doing tests, the alternate hypothesis is what they're trying to prove, or the answer to the question that they're asking. Is Facebook cool? More than 85% of people think so, right? That's the question that they're trying to answer, right? Do students get the financial aid on time, right? So then the null hypothesis is students will get their financial aid by the end of the second month. The alternative will be it'll be less than the time will be less than by the end of the second month, right? That's the question you try and answer, be your alternate hypothesis. All right, this is a right-tailed test. All right, and so we have compute the test statistic Z. And again, this is that fancy formula, right? Again, this formula you will have to memorize. It will not, you're not given formulas on the test. But also salt will calculate it for you as well. And so P hat is going to be 450 out of 500. So that's going to be your P hat. And so therefore, your Q hat, what's Q hat going to be? P hat is 9%. So what's Q hat going to be? 0.1. Yes. And so then you plug all of these into your fancy formula, and that gives an answer of 3.13. So that's how you find C. All right. Questions there? All right. So let's go ahead and do the rest of the problem in salt. So let's go find our best friend in the whole wide world, Mr. Salt. Mr. Salt. Turn me over. Again, so in salt right here, what you'd want right here is over here, inferential statistics. Again, same thing we used before, but this time right here, we're going to select a one sample proportion as our selection right here. For your one sample proportion, you only need two numbers, well, three. You only need two numbers right here. The number of successes was 450, correct? Out of a total of 500 people who were asked. Is that okay? Is that okay? And what is the value for P? 0.85, 0.85, not an 80. And then this is going to be a right-tailed test. So you're going to hit on greater than right here. Questions there? Again, one sample proportion is pretty straightforward. You just need the two numbers, and then your probability is going on today. Questions there before I hit the generate button and we're finished. Questions there? So you hit the generate button right here, and you have it right here. So you see the test statistic they just calculated by hand. You have your test statistic right here, and then you have your p-value. Of course, you should always first and foremost check your null and alternate hypotheses to make sure that they're correct, because if they're not, that throws everything else off. Okay? And so null P is 85%, alternative, more than 85% of female college students think Facebook is cool. And so you have your p-value right here. So the alpha level was 5%, I believe, yes? Do we reject the null hypothesis and i.e. select the alternate hypothesis, or do we fail to reject the null hypothesis? Think about it. I have the p-value right here. Think about it. The alpha level is 5%. Oh, you're not raising your hand. 1 second, think about it. Answers locked in. All right. All those who think the correct answer is to reject the null. All those who think the correct answer is to fail to reject the null. All those who have no opinion yet. All right, so then let me go back over for you guys right here. The basic idea right here about a hypothesis test right here is we're looking at we're having a jury trial on the null hypothesis, top high hypothesis. That hypothesis we believe is true. Yes? And so if I run a test, I get a p-value. A p-value can be thought of the probability that the null is true. Not really, but you can think of it as the probability that the null is true. Right? This is saying that the probability that the null is true is 0.87%. It's a really 0.0087%. It's a really small percent chance that the null is true. Right? Do you really think we should stick with the null? No. This is literally saying the probability that the null is true is almost non-existent. It's a small number. So in other words, it's saying that throw this out. This cannot be relied on. So if I'm rejecting the null, then it means I must accept the alternative hypothesis. All right? But along with that, we have to have some kind of standard. What happens if this number is a little bit higher? Let's say this number is 1%. Should I still reject the null? If this number was 20%, should I still reject the null? Right? And that's where the alpha level comes in. This number right here, see this 5% right here? This 5% is a cut-off figure. Anything that is below this number will, for your p-value, would say we have to reject the null hypothesis. Okay? It is a 5% figure, it's a cut-off value. You can think of this in one of two ways. The first way you can think about it is, hey, the probability that the null is true, we don't want just a 50-50 split. We want strong evidence that the null is not true. And so because of that, we only want a small percentage chance that the null is true. Yes? The other way you can think about this is, well, if the alternate is true, then the null is not going to be true, right? So if the alternate is true, then the null will have a small percentage of being true. Right? And so if I have a small percentage true for my null, then it means I need to switch to my alternate hypothesis. Is that better? Is that better? And so the basic parameter right here is you calculate the p-value. I just showed you how to do it. They're going to do it by hand, but we're not going to do it by hand. And they got, this is the same number we got right here. Actually, our number is a little bit smaller, it's 0.008. But they're close enough right here. And then what you do is you compare this number to this number right here. Okay. If this number is smaller, you reject the null. Your p-value, make a decision. Since this number is smaller than 0.05, you reject the null. And once we've made a rejection of the null, we can make a conclusion. And that conclusion is we're going to choose the alternate hypothesis. Right? Let me do it this way right here. This has been rejected. So this must be, we can accept this to be true. And thus, you can write this conclusion. There is enough evidence at the 0.05 level that more than 85% of female college students think Facebook is cool. Questions there? Yeah, I'm pretty sure when they rewrite this textbook, they're going to change this problem. I tell you. They show you how to run it on a TI-83 calculator, and then they will show you how to run it on SALT. Let me just go back over the SALT again. So in SALT, you have to select a one sample proportion, and it'll ask you for two numbers. Once you select those two numbers, you then have to write out the alternate hypothesis. And so this right here, and then it's a right tail test, so you're going to select greater than. Questions there? You hit the green button, generate. Now, when you hit that green button, generate right here, it produces these results. Again, the first thing that you should do is check the, The first thing that you should do is check the null and alternate hypotheses. Because if those are wrong, nothing else will make sense, right? Imagine if you had a left tail test, then the p-value will switch to the other side. The p-value will be 999. The p-value will switch sides. So this right here has to be right. And then if they ask you to calculate the z statistic, some of the homework problems ask you to do it, it's right here. And then here's your p-value. Questions there? By the way, sometimes this is called your test statistic as well. And so once you have that test statistic right here, you got your p-value. You got to compare the p-value to the alpha level. Oh, and last thing right here, your p-hat is just divide these two numbers. That's the formula we gave you a little bit early on, R divided by N, 450 divided by 500. Again, what this is saying is that for their sample, 90% of the female students they talked to thought Facebook was cool, right? That's strong evidence that is more than 85%, yes? Yes? And that's why it ended up working out that the alternate hypothesis was true. All right, last thing right here they want to point out to you right here is that sometimes it's kind of hard to tell which side is shaded or not because such a small amount is being shaded. And what you have to do is kind of look at the end. You see right here at the end, like this little bar is missing. While on this end right here, the bar keeps going, right? If the curve continues after the tick, then the tail is shaded. So this side is shaded and this side is not shaded in the homework problem. Okay? Students sometimes complain about figuring out, they all look the same. All four problems look exactly the same. Well, it's the edges right on the last edge is what you look for. This side is shaded, this side is not shaded. Again, it's the reverse. This side over here is shaded. And of course, if both of them extend out, then both sides are shaded. Questions there? All right, so that's it for all the course material. The Unit 6 test is on Monday. I actually finished all this stuff by April 9th. That must be some hard work. It will be a Monday, April 20 or April 21st. April 20, April 20. I sent out an email with the, I'm gonna just pull it up. I'm just gonna pull it up. I'm just gonna pull it up. Oh, if you haven't done so already, go ahead and do it now. The climate, the class climate. Wrong class section. All right, so announcements. You guys be reading my announcements? Or just be pretending to read my announcements? All right, so I posted the video from 8.2 from Wednesday. I posted that video. The final exam will be on Wednesday, April 29th from 3 to 5 p.m. Test 6 will be on Monday, April 20. Has everyone done the class climate survey? Go ahead and do it now for me, please. If you log in right here, right at the bottom, right here, family class climate should be available. And then you can click on that, and that will give you a lovely quiz to take. Please do so.